Bite my shiny metal.
I've been using my Creality Ender V2 Neo for about 6 months now with a Raspberry Pi Octoprint setup. I can honestly say it's been a really great combo for me. I'm going to go through the pros and cons of this. Hopefully you can evaluate for yourself whether it's something you really want to do. For my day job, I'm a manufacturing engineer. I deal with lots of CNC equipment, lathes, mills, water jets, all that kind of stuff that you can ever think of. So 3D printing is just basically a small CNC machine. Through having this kind of job, I have access to a more industrial version of 3D printers. One such line is called Markforged. If you stay tuned until the end, I'm going to show how a setup like this can compare to an industrial printer that costs above $40,000. And I'll actually tell you what things this can actually do better than an industrial printer. I've gone through several hours of prints on this setup within the last 6 months. Mostly in PLA, but I've also tried some carbon fiber PETG, which failed miserably. I'm currently working on some carbon fiber PLA, which is actually working out pretty well so far. For my Octoprint setup, I actually got the enclosure off of Amazon, and inside there's a Raspberry Pi 4, and the enclosure has a built-in fan feeding off of the power source of the Raspberry Pi itself. So it's kind of a nice little enclosure to keep the unit cool. Does a pretty good job. I haven't had any complaints so far, and this is in a shed with no climate control at all. If you need help getting your basic Octoprint setup going, I would recommend this video from Made with Layers. It's down in the description. Go check it out. He helped me get it going, and it was really easy if you just follow the instructions. I have my entire setup outside of my shop, and it's actually done really well using mostly PLA. And this is in a metal building, obviously with no insulation, no climate control, and it's actually performed really well even in 110-degree heat.
Fire!
There's not a lot of resources that actually say whether you can do this or not, but actually it really printed extremely well within the hot days of summer. This is a multi-purpose shop, so I do a lot of things out here. I do woodworking, I do varnishing, painting, all kinds of stuff, and as a multi-function shop, this printer being out here hasn't really been a problem. It gets dust all over it, and as long as you clean it off and keep it sort of maintained, it's done pretty well. I cannot speak to the longevity of the equipment at this point, and I do plan on building an enclosure, but so far it's done pretty well. I've rarely had issues with my prints, even when executed from a distance using Octo Everywhere, which if you don't know is a service that allows you to access this printer via your Octoprint setup over the network for free. They do have a subscription version to help support them and their servers, because they actually have to host all of this on servers to allow you access. So there's a service fee of about $5 a month, and you can have unlimited webcam viewing. You get notifications. It actually has spaghetti detection, and it has alerted me through email about whether it detects some issues with my print. It'll send you a little picture from your webcam and say, hey, you know, possible issues with your print. You might want to check on it. So it will email you these, and it's actually been pretty helpful. For a small amount a month, I think it's actually supportive of the industry. They can actually serve a lot of people and makers in the community, so I think it's pretty worth it. The webcam I have is an old Logitech, and it does pretty well. I haven't had any issues. It's a little grainy. You can see through the display on the phone, and it does a pretty good job. It does really great time lapses for me. I could get a higher resolution camera, but for now, this has worked really well. The only reason I would update for a higher resolution camera is simply to have better videos for this channel. The Octoprint setup has a native ability to capture time-lapse videos of your prints. It does a pretty good job with this. It'll store it on the SD card, which is essentially the hard drive for your Raspberry Pi. So when you're doing your disk imaging to set up your operating system, you basically put it on an SD card, which acts as your hard drive for the controller. One problem I had with this is I started with like about a 4 gig SD card, and if you're doing multiple time lapses over time, you either have to go through and cull them out and delete them or get a larger card. But to do this, I had to re-image, reset it up. I had to redo everything in order to get it connected in here again and swap it out. It wasn't really that big of a deal, but if you anticipate needing a lot of storage, having a lot of G-code files and a lot of time lapses, then I would highly suggest going with a higher gigabyte card. I've got about a 64 gigabyte on here right now, and it's done pretty well. Can't really tell if I'm going to fill it up anytime soon. One of the really great apps you can get for the Octoprint, it has a whole list of apps that you can go into and add to your server, because this is considered a server. That's how they term it. You can go look at several apps that have been posted on there to add to your Octoprint server, and one of those is Octolapse. Octolapse is responsible for some of the better time-lapse videos. You can see where the print just magically starts growing and expanding, and next thing you know, it's done, because it moves the camera out of the way so it can take a still picture for it, and it creates much better videos for you. The only real difficulty I've had with Octolapse at this point is that it travels very quickly from the same point over and over again and creates a stringy mess along the seam from the travel point away from the material. And I'm sure there's some settings to fix this, but I haven't figured that out yet. The only other real difficulty I've had with the setup being out here in a non-climate controlled building, when the temperature dips down below freezing, I've had stringiness and bad surface quality on my prints. And this is why also, along with the dust, that I would really plan on building an enclosure for this in the near future. In the wintertime, you're definitely going to need something to keep and retain the heat if you're going to keep it out in a non-controlled environment such as this. In the future, as a teaser, I'm actually planning on doing an extruded aluminum framework for the enclosure that'll have plexiglass windows all around the sides. So it'll be hopefully a slick, really visually interesting setup so I can actually watch my prints happen and keep it warm at the same time. It'll be a build that I'll probably share plans for later on. Now that we've gone over my setup and my druthers along with that, I can start comparing it to the Markforged printers that I have access to at work. The models that we have are actually the X3 and the Mark II. They're specifically designed to work with a material known as onyx, which is proprietary to Markforged. What it is a nylon with carbon fiber throughout the filament. But it does create a very resilient material. Nylon itself is inherently resilient, although fairly difficult to print, especially with a printer like this. Unless you replace the entire hothead and do lots of work on it and fine-tuning for your programming. It is possible, but these machines come prepared to do this material straight out of the box, and they do it very well. This material and its resilience does a great job creating some wear-resistant parts and some very tight tolerance parts. You know, you can do some press fits, you can do some things that should fit together. The Markforged printers can do PLA and other materials, but just like this one is tuned to PLA, they are tuned to their proprietary filament called onyx. So just like switching this one to another material, switching a Markforged printer to another material like PLA requires some work, although it is technically possible. The X3 has a laser leveling system within the bed, not unlike the CR Touch that these have. I think it just measures with a laser, therefore it's technically more accurate. I think it's more of a bragging point. The bed itself that they have is a proprietary material. I can't tell really what it is. It's a very hard, resilient material, and it doesn't show wear, and the nylon inherently sticks to it. The bed adhesion is really good. So whatever they did for that material, it'd be nice to know. But it's a very nice printer overall. Just like if you install Octoprint on your Creality or another printer, it doesn't have to be one of theirs. The Markforged printers have cloud-based slicing, so you upload your STL to their software called Eiger, and you log in, you have access. I'm sure you pay for it, but I haven't verified that or not. I don't know if it comes with the printer or whether you just have to pay for service. Upload your STL, you slice it, you put it on the bed, it mocks it up just like Cura would, and you can see the mock-up on the printer. You can map it out and nest your parts and make sure that everything's good, and you hit print. And it goes over the Ethernet and starts your print, just like I did on my Creality using an Octoprint. This system also tells you when it's time for maintenance issues, such as replacing your Bowden tube, other things like that, belts, whatever. I think it's actually a lot more frequently than is necessary because they're selling you the parts, therefore they want you to replace it more often. You know, it could be debatable as to how long these wear points actually take to be replaced, but still it's kind of a helpful reminder, kind of do your total preventative maintenance type thing. The machine itself for a Markforged comes with the built-in enclosure. It's all snazzy and has curves and really cool plexiglass and looks super futuristic. Comes with it, but only, like I said, for the nice price tag of about $40,000.
Game's over, losers! I have all the money! Compare your lives to mine and then kill yourselves!
So with all the specs lined out, we can start comparing the Markforged to a basic garage setup that I have that I spent maybe under $500 for. So if you make a few slight modifications, technically a Creality Ender version printer can print nylon, and therefore technically can print carbon fiber nylon, or at least several YouTubers on here say you can. I haven't gone through the replacement of a hot end to see if I can actually do it, but technically with an enclosure and a new hot end and a few tweaks, you should be able to do it. Now, fiddling with a printer isn't necessarily my favorite thing to do, so I've typically reverted back to PLA because that's what this printer does best right out of the box. If my experience with printing carbon fiber PETG is going to be the same as trying to convert to nylon, I don't know if it's necessarily something I want to do.
I hate it here.
There are a lot of really great videos here on YouTube analyzing the tensile strength of materials for 3D printers. Some of those are somewhat inconclusive. People can make assumptions about the material strength based on the performance of that. Nylon inherently has some great material strength to it, has great impact resistance. I think it has a higher tensile strength, or therefore a higher Young's modulus. I would really argue that design of your parts plays a much more critical element in the strength of your parts. So material can do quite a bit. Your part geometry plays a very large role in that. I have not seen any of these tests do a compression test based on other materials. You can do a tensile, you can do a compressive test, you can do a brittle test where you hang it off the end and try to break it to see how much force it takes. There's lots of ways to measure a Young's modulus, but materials perform different ways when put under tensile or compressive strength. It depends on the application as to whether these materials will work well for you. The whole reason why I go through all of this discussion is that the carbon fiber nylon, it's actually quite resilient, does a really great job. I've used it in a CNC cooling environment for about 1.5 years, and it's still being used in this CNC machine. Now, it is a hygroscopic material. Technically, it should swell when exposed to this moisture. However, it has survived and is still in use in a production environment. So this carbon fiber nylon can be quite good, but I think you can get a decent material for this machine if you're willing to spend the time and tweak it. With this material, the Markforged printers can actually produce a very high accuracy print. To be honest with you, I've actually been able to reproduce good results with this printer. It might require a test print to get a size right so you can reprint again, but still, you tell it to get a certain size, it's just within a couple of thou. So technically a Markforged printer can print in this ultra special material that they have only, but theoretically, an Ender can be converted to that, or a Prusa, not sure, or a bamboo. They may actually already be able to do this type of material. There's another example of a cheaper printer than a $40,000 industrial printer that would already be capable of a nylon material. I do find that there's a lot of back and forth to fine tune the material through Cura to get it to the printer to see how it's going. You can even see right now some of this carbon fiber PLA is stringing on the surface right now because I'm having to go through this edit back and forth prototyping process to make sure it's getting the right settings to be able to print correctly. It's absolutely infuriating to have to go back and forth trying to make sure this works, because if you're interested in the end product and you just want to get a job done, switching materials just isn't worth it. What's funny is this is a PLA. You add carbon fiber to the filament and it adds an extra variable that you have to account for in order to print correctly. It's either that or it's bad filament. I can't tell yet. Markforged printers automatically come with a stylish enclosure ready to go right out of the box, but are they worth the $40,000 price tag? Some of my fellow engineers at work actually believe that you could achieve the same results or better with a cheaper printer, such as one of these, using an Octoprint setup. There are a lot of ways in which this actually does better than a large-scale industrial printer. With Octoprint added on to a printer, you can actually achieve much more customized results with all the different apps that you can add to it. You can do a lot of things. You can control lights, you can control your time lapse, you can actually take video and record it. The Markforged printers actually only will take a still picture to give you a progress update for the print you're working on. So it's not necessarily the greatest thing. You can see that it's not failed yet, and it does have spaghetti detection built into the Markforged software, but the resolution is not as good as even this cheap webcam that I put on here from Logitech. A time-lapse video isn't even an option. And like I mentioned earlier, if you want to get a better camera for this, you can. You can do whatever. If it'll fit into the USB port on the Octoprint box, you can get a great resolution on this, which is not even an upgrade possibility on a printer like a Markforged, because it's all proprietarily linked. It's something they designed to only work with itself. So this allows you quite a bit of customizability. It does so at an affordable price. So like all choices, it comes down to a convenience fee, essentially. Are you willing to pay $40,000 so that you don't have to tinker with this to try and get it converted to a new material, or are you willing to put in the time to save the money? And I know most of you aren't thinking about getting a Markforged printer. You probably hadn't even heard of it until this video, but it's worth comparing something that is an industrial standard that's actually pretty good, although expensive, to a custom setup that you have in your own shop that is attainable, that is something you can get. You know that for an affordable amount of money, you can get a really good setup and you can do a lot of great prints. The only difference is your desire and ability to get it done, and your money. That said, the Octoprint setup was really actually pretty easy to follow through with. As long as you go through some YouTube tutorials, you can get almost anything you need. There's a lot of great videos on here that actually tell you how to do this. I just wanted to talk about its usefulness, its practicality, hopefully enlighten you on the possibilities of what you can do with it. And I'll leave a lot of information in the description below. It's really nice that you can use the app on a phone, upload my G-code generated from Cura into my iPhone, up to my iCloud account. And then I download from my iCloud account to my phone from like this is all going from a computer to the cloud to the phone. The app I'm using is Octopod, and there are several out there that you can use, and you can start a print from your phone, and you can keep an eye on it because you can watch the live video feed using Octo Everywhere to be able to check on it and to see what's going on. And Octoprint or Octopod actually does a live % status completion rate on your phone, and it displays it on the front of your phone, so you can see how far along in your print you are. And then via email, you can get updates as to whether you're having some issues or not. So Octo Everywhere will send you spaghetti detection emails, or it detects like the strands and the weird loose filament everywhere, and it'll tell you, hey, you might have a possible issue. So you have percentage completion always on the front of your phone, so you can keep an eye on your prints if that's important to you. You have alerts through Octo Everywhere that you can see whether you're having a problem or not, and it'll tell you, hey, I need to look at my live feed, see what's going on. And you can make sure and do work while you're doing other things. So you could be in bed at night starting a print as well. So the convenience of this is enormous. And if your time management is very, very tight, you can do a really good job if you can just get the prep work out of the way. Design your STL, put it in your 3D slicer of choice, and then generate your G-code, store it in your iCloud account or your Google Drive. You can upload it to your app and you can start a print. If you do some prep work, you have a large convenience of keeping an eye on your stuff while you're doing other things. And this machine can work for you while you're doing other stuff, which is really great for me because I don't have time to tinker around and watch it happen. I mean, it's really nice to get a head start. So you can start it at your lunch break. You're already 4 hours ahead on a long print. You can kind of get a jump on it and then see how your print is looking before when you get home. You have a chance to revise, you can start it again and let it run overnight. Now that being said, everybody says don't let these things run on their own, they're a safety hazard, but I think with a webcam monitoring software you can keep an eye on it, or if you have alerts set, you can make sure things are safe. With that all said, I actually think you can obtain some really good results with a very cheap printer, and I think Octoprint is a very good interface to help you do that. This is from a manufacturing perspective. I think it's quite resilient, it's quite simple, and I think that you can do quite a bit with it, and I have only begun to push the boundaries of what this machine can do. Thanks for tuning in, and let me know if you have any comments in there down below. And as always, please subscribe and stay tuned for more maker things.
What the hell?
Yo.
You call that an antenna?